Hey there, welcome back. Today we're going to zero in on some special triangles called 30, 60, 90 triangles. We saw these back in geometry, and part of what we're doing today will be a review of finding the sides based on the relationships. God's handiwork shows up all over these 30, 60, 90 triangles, and what we're going to talk about tomorrow, the 45, 45, 90 triangle. Just some really cool stuff. These ratios that we're going to develop, they hold for every 30, 60, 90 triangle in the entire universe. It doesn't matter what size they are. So it's really kind of neat. So anyway, let's get started. We're going to solve for missing measures. We're going to be back in proportions. I'm going to compare a technique using proportions to what we did a couple days ago using the calculator. So let us go. All right, a 30-60 triangle. The relationships of the sides are always, okay. When you have a 30-60, let your short leg, which has to be opposite the 30 degree angle, the short leg, okay, has to be opposite the 30 degree angle. Always define it as x, all right? Let that one be x, okay? Then your other two side lengths have x in them. So once you know x, then you can calculate the other two. Not to worry, you can get to all three of them by just knowing one, but let's just start with the x here. Short leg, let it equal x. Okay. Your hypotenuse, which is always across from the 90 degree angle, right, is always twice the short length. So it's 2 times x. The hypotenuse is always 2 times x. So if you know your short leg, you can get to your hypotenuse by doubling it. If you know your hypotenuse, you can get to your short leg by dividing it in half, right? Now the long leg, this is the one that trips kiddos up most of the time. The long leg is your short leg times the square root of 3. The short leg times the square root of 3. Okay, so given one side, let's figure out all the other two sides. All right. So first you have, when you're given a triangle, let's just focus right here. Okay. All right. First determine what side they've given you. In this case, look, the dimension that we know is across from the 30 degree angle, so it has to be the short side. So that says x has to equal 5. Okay? You say, well, why x? Well, that's just a way to keep things straight. X is always our short side, so x has to equal 5. Okay? All right? It has to be the short side. Now, the long leg has to be the short leg x times the square root of 3. Right? Well, what's x? It's 5. So the long leg has to be 5 times the square root of 3, just like that. That's the length of the long leg, 5 square roots of 3. The hypotenuse, right here, across from the 90 degree angle, all right? You might want to mark these. I apologize, I forgot to mark those. Across from the 90 degree angle, that hypotenuse is always twice the short leg. What's my short leg? 5, so it is 2 times 5, or 10, just like that. So this side has to be 10. All right? Next one. What are we looking at here? We have 2 square roots of 3 over here. Is that the long leg or the short leg? Well, it's across from the 60 degree angle. So it has to be the long leg, not the long side. The hypotenuse is always the longest side. This is the long leg. So how do I get to the short leg? Well, I back into it using my long leg. My long leg is always my short leg, which is x, times the square root of 3. All right? What is my long leg? Plug in. It's 2 square roots of 3. Now, I can divide both sides by the square root of 3, and what does my long leg have to equal? My short leg have to equal? 2. X has to equal 2. This is the only thing that's left. X has to equal 2 because those square roots of 3 cancel. All right, so I was given this one. Okay. All right, now I had to find my hypotenuse. Well, my hypotenuse is always 2 times my short leg. What's my short leg? X. What's 2 times x? Well, that's 2 times 2, and that equals 4. So my hypotenuse has to equal 4. Not so bad, right? Here, they give me my hypotenuse. So I know that 2 times my short leg has to equal 6. Notice how I'm starting down here with the hypotenuse. Okay? Then I divide both sides by 2, which tells me that x has to equal 3. So my short leg, x, has to equal 3. This is 3. So what is my long leg? Well, my long leg has to be my short leg, x, times the square root of 3. So I just get, x is 3, I just get 3 square roots of 3. Just like that. Hopefully it's not too difficult for you. Okay. All right, let's try this one. I have here my 90 degrees here and here. Okay. So what am I provided? What is this? That's x. That's my short leg because it's across from my 30-degree angle. So my short leg is x is equal to 7. Right? How do I find my long leg? Well, it's the short leg x times the square root of 3. Short leg x times the square root of 3. Well, what is my x? It's 7, so that means I plug in 7. Seven times the square root of 3. That's my long leg. So over here I'm going to write 7 square roots of 3. My hypotenuse is always twice my short leg. So I get 2 times 7 is equal to 14. And it's done. Right? We're getting these using no trig values at all. Okay, that's the beautiful thing about 30s, 60s, 90s. Okay, all right. Short leg. I got to find my short leg. What am I given? I'm given my hypotenuse. 14 has to equal 2 times x, right? So what does x have to equal? And what does x stand for? My short leg each and every time. So how do I find my long leg? I just multiply it by the square root of 3, and I get 7 square roots of 3, and I'm done. Okay. Now here we have the long leg. How do I know that? Because my long leg is always across from my 60-degree angle. So I'm going to start down here. My long leg is equal to x times the square root of 3. So I have 8 square roots of 3 is equal to x square roots of 3. My square roots of 3 cancel. What does x have to equal? 8. So that means my short leg has to equal 8 because my long leg equals 8 square roots of 3. I'm given that. So this one has to be 8. So how do I find my hypotenuse? Well, it's just 2 times x, and 2 times x is 16. Just like that. Not so bad. One of the hardest things is when the radical doesn't occur in the spot that we think it should, like on the long leg. So, or we have a whole number on the long leg. It's okay, because then we just are going to divide through by with a radical, and we know how to do that because we know how to simplify and rationalize our denominators. Okay, so this is my long leg, and it's 7. So I'm going to start here in the long leg piece. And I have 7 has to equal my short leg x, here's my short leg, times the square root of 3. How do I solve for x? I have to divide both sides by the square root of 3. When I do that, I have to rationalize my denominator over here. Okay? So that means x has to equal 7 square roots of 3 over 3. Seven square roots of 3 over 3. So here is 7 square roots of 3 over 3. How do I find my hypotenuse? Well, I multiply this side by 2. So it's just 2 times 7 square roots of 3 over 3. And I get 14 square roots of 3 over 3. I didn't do it down here because I felt like I was going to run into my little controls there. Alright? Oh, look here. I'm given the short leg. Okay? So I know that x is equal to 4 square roots of 3. 4 square roots of 3. How do I find my long leg? Well, my long leg has to equal my short leg, x, times the square root of 3. X is equal to 4 square roots of 3. So I plug this whole thing in, and I get 4 square roots of 3 times the square root of 3. What does this become? Just 3. So this is 4 times 3, and I get 12. So my long leg is now 12. How do I find my hypotenuse? I just take my short leg and I multiply it by 2. My short leg is equal to 2 times 4 square roots of 3. What's 2 times 4? 8. 8 square roots of 3. So here is my hypotenuse, 8 square roots of 3. Alright? Now I'm given my hypotenuse right here. I know that because it's across from my 60-degree angle. I'm sorry, my 90-degree angle. Alright, so this has to be my short leg. Alright, how do I find my short leg if I know my hypotenuse? Well, if I start here with the hypotenuse, I know that 4 square roots of 3 has to equal 2x, right? So I just divide both sides by 2, and that'll tell me what x is. X has to equal half of that, 2 square roots of 3. My long leg, this is going to be 2 square roots of 3. My long leg is my short leg times the square root of 3. My short leg already has a square root of 3 in it, so I go 2 square roots of 3 times the square root of 3. These become 3, and then 2 times 3 is equal to 6. So my long leg has to be 6. Okay? All right. The cool thing about 30, 60, 90s, and we'll see this for 45, 45, 90s, is that if we plug in this general relationship between sides, not actual numbers, but algebraic expressions, what happens is that we can get exact trig values for every 30-degree angle in the universe, for every 60-degree angle in the universe. Watch how this happens. All right, this slide here, I'm concentrating only on the 30-degree angle. Here it is right here. What is my side opposite? O. It's x. What is my hypotenuse? 2x. And what is my adjacent side? X times the square root of 3. Now let's just plug these in and see what we can cancel out. Alright, the side opposite is x. So I plug in an x. The hypotenuse is 2x. Now if I have x divided by x, what does that become? 1. They cancel. So this simplifies to 1/2. The sine of every 30-degree angle in the universe, regardless of the shape of the triangle, regardless of the size of the triangle, the sine is always 1/2. The ratio of the opposite to the hypotenuse is always 1/2. That makes sense. Why? Because my hypotenuse is twice as long as my side opposite. Okay? Now let's plug in for cosine. Well, cosine is the adjacent over the hypotenuse. What is my adjacent? I have x times the square root of 3. What is my hypotenuse? 2x. I have an x in the numerator and an x in the denominator, and they're going to cancel. So I'm just left with the square root of 3 over 2. Every 30-degree angle has the ratio, regardless of the size of the triangle. If you have a 30-degree angle, its cosine is always the square root of 3 over 2. Right? The tangent of a 30-degree angle is the side opposite over this should be not an H, but it should be an A. My bad. I think I fixed it on yours. That's an A. My side opposite is X. My side adjacent is X times the square root of 3. Look what happens. I get 1 over the square root of 3. And when I rationalize that denominator, hopefully by now we're seeing how this works. We just end up with the square root of 3 over 3. Because we multiply top and bottom by the square root of 3. All right. Now, the 60-degree angle. Here we go. Okay, we're developing these ratios for the 60-degree angle. Here's my opposite, here's my adjacent, here's my hypotenuse. So my opposite is x times the square root of 3. My hypotenuse is 2x. My x's cancel, and I end up with the square root of 3 over 2. The cosine of 60 is the adjacent side over the hypotenuse. My adjacent side is x. My hypotenuse is 2x. My x's cancel, and it's 1/2. The tangent of 60 degrees is opposite over adjacent. So I get x times the square root of 3 over x. My x's cancel, and I'm just left with the square root of 3. And you can write the other 3, and I have you do that as part of your homework. Okay? Not too bad. Not too bad at all. All right. The key to getting answers correct on tests is to look for the word exact value. If it asks for an exact value, stay in radical notation. That means use these ratios, these consistent, beautiful ratios, 1/2, square root of 3 over 2, square root of 3 over 3. Use those ratios and set up a proportion, all right? So there's usually more than one way to solve this triangle. We want to solve for x. If we can, on the 60-degree angle, let's just focus this right here. Let this side go for a second, okay? We're going to focus in on the 60-degree angle. I have the sine of 60 is the opposite over the hypotenuse. Hasn't changed, all right? But now, what we developed on the previous slide is that the sine of 60, we can just substitute in the square root of 3 over 2. Now all we have to do is cross multiply, and we come up with x times the square root of 3 is equal to 2 times 7 is 14. So that means x equals the square root of, oops, my eraser, equals 14 divided by the square root of 3. And then I just multiply by the square root of 3 over the square root of 3. And I get 14 square roots of 3 over 3. Just like that. Okay? If we had done this using the short leg, long leg technique, I know that my long leg, 7, has to equal some number. I'm not going to call it x because this is x here. Equals some number, I'll call it s for short leg, the short leg times the square root of 3, right? So if I have to find my s, I get my short leg, I get the square root of 3 over the square root of 3, right? So s is equal to 7 square roots of 3 over 3. Now I need to find my hypotenuse, right? Because this is across from the right angle. So I multiply this by 2, and I get 14 square roots of 3 over 3. I get the same answer both ways. Okay? All right. Another way of looking at this, I'm going to erase some of these little marks here, okay, is to view it from the 30-degree angle and say, oh, I have the adjacent side, and I'm looking for the hypotenuse. Well, the cosine of 30 degrees is square root of 3 over 2. So now I just cross multiply these, and I get the exact same answer. The cosine of 30 is always going to be the same as the sine of 60. So I would get x times the square root of 3 is equal to 14. Divide by the square root of 3. X is equal to 14 over the square root of 3. And then times the square root of 3 over the square root of 3. And I get 14 square roots of 3 over 3. 3 ways, all the same answer. Okay? All right. Let's try this one. Find the exact value of x. Use the ratios we develop. Anytime we want exact, we want to use those exact values. The 1/2, the square root of 3 over 2, the square root of 3 over 3. Here's my 30-degree angle. Okay? So this is my opposite, and this is my adjacent. So which trig function should I use? Tangent. What is the tangent of 30 degrees? The tangent of 30 degrees, if we go back to the tangent of 30 degrees is the square root of 3 over 3. So we're going to plug that in. So I have the tangent of 30 is equal to 6 square roots of 3 over x. This is nothing more than the square root of 3 over 3. All right, so now I cross multiply, and I get x times the square root of 3 is equal to 3 times 6 is 18 square roots of 3. So now my square roots of 3 cancel, and I have the x that I'm looking for is equal to 18. Notice that this x doesn't stand for the short side. It's the missing piece you're looking for. Okay? So sometimes you have to pay attention to which mode you're in. All right? All right, let's do this next one. I have a 60-degree angle here, and this is my side opposite, and this is my hypotenuse. So which trig function is OH? Well, that's sine. So I have sine of 60 degrees has to equal what? X over 23. Now they're asking me for exact, so I'm going to use that ratio for the sine of 60. Sine of 60 is the square root of 3 over 2. Now I cross multiply and I solve for x. So I get 2x is equal to 23 square roots of 3. So x is going to be 23 square roots of 3 over 2. Or like 11.5 square roots of 3, right? So this is 23 square roots of 3 over 2. That's the exact value. Okay, try one more. Couple more. I have a 30-degree angle. I want to use the ratios because it's looking for exact. All right. So it's good to know those ratios. Keep your slides real close to you so you can in your homework. All right. So my side opposite, my side adjacent. So I have tangent again. Tangent of 30 is equal to opposite over adjacent. I'm going to plug in. Tangent of 30 is square root of 3 over 3. You could write it as 1 over the square root of 3 in this case. And I'm going to have, here's my O, 4 square roots of 3 over x. So I get x times the square root of 3 equals 12 square roots of 3. So x has to equal what? 12. So this has to be 12. If you were asked for this one's easy. That's just going to be 8 square roots of 3. Double that. Okay. All right. Next one. I think this might be the last one. All right. Here we go. I have opposite over a hypotenuse. Oh, that's a sine again. So we have the sine of 60 equals the opposite over the hypotenuse. Sine of 60 is square root of 3 over 2. Has to equal, x over 2 square roots of 3. Cross multiply. I get 2x is equal to 2 times the square root of 3 times the square root of 3. This double just becomes a 3, so I get 2x is equal to 6. X is equal to 3. Did I do that right? So this is 3. And this is half, so this is just going to be the square root of 3. Like that. All right. Oh. All right, here we go. Got some more. These the same. X is 4 square roots of 3, that's a 30. And x is 2 square roots of 3. It might be a double. Yep, that's an extra. I probably wanted to do a couple more examples, but those are the same, so I'm going to skip those. I'll have a homework sheet for you. It might be beneficial if you have time right now to start writing the trig functions for the 30, 60, 90. Try and get as many of them from memory as you can. Remember that the 30-degree angle, your side opposite is going to be the short piece, so that's like a 1. Maybe that help you get in. I can show you some tricks tomorrow. Thanks for watching. Appreciate it. And I will see you tomorrow. Bye.